be doing class 8 physics today, and the topic for today is light. So we'll continue we'll continue with the same chapter, and the name of the chapter is light. So the first, in the beginning, we learned about refraction, then we learned about the terms related to refraction, then we learned about effects of refraction, then we learned about refraction through a rectangular glass slab, then we learned about refraction through a prism, then how rainbow is formed, dispersion, isn't it? Then in the last class we learned about the spherical mirrors, the two types of spherical mirrors that are concave and convex. And we learned the important terms related to the mirrors, that is center of curvature, principal axis, pole, focus, focal length, and radius of curvature. So today we will continue with the chapter, and today we will be discussing about the type of ray diagrams. Okay, what happens when the ray falls on the, what kind of reflected ray or what kind of images will be formed when the rays fall on a concave and convex mirror. So before we start, there are certain rules that you need to follow, okay, for a ray diagram. So the path of three ways that are known is used to construct the ray diagram. So these are very important, okay. When you are drawing the ray diagrams, you need to remember these three things. These are very important. So every time you are drawing ray diagram, these are the three things that you need to remember. So every ray diagram begin with this one, okay, be it for convex and concave mirror or convex and concave lens. Lens you will be starting in class 9. Here we will be discussing about mirrors. So first one, rays traveling parallel to the principal axis are reflected and appear to be coming from the principal focus. That means if the ray is parallel to the principal axis, then the reflected ray will pass through the focus. See, when a ray of light which is parallel to the principal axis gets reflected, it passes through its focus. So this is how it looks like. The red line, this line is your incident ray. Okay, this line is your incident ray. Now this is parallel to the principal axis. This is your principal axis. So this line is parallel to the principal axis. So when it falls and strikes the mirror, what will happen? After striking the mirror, reflecting surface of the mirror, it will reflect back. And when it reflects back, the reflected ray will pass through the focus. Okay, the reflected ray will pass through the focus. This is true if the ray of light is parallel to the principal axis. So this is your incident ray, this is your principal axis, they are parallel. So when the incident ray is parallel to the principal axis, after striking the reflecting surface of a concave mirror or a convex mirror, it will pass through the focus. Okay, it will always pass through the focus. This is your first rule. The second one, when a ray of light passes through the center of curvature, it gets reflected back along the same path. So if the incident ray passes through the center of curvature, the reflected ray will also pass through the same path. That means center of curvature only. Now see here, there is only one line that you see here. But see from the arrow. This arrow shows, the arrow which is pointing downwards shows this is your incident ray. So this is your incident ray. Now incident ray passes through the center of curvature. What does C represent? C represents center of curvature. So when it passes through the center of curvature and it strikes the reflecting surface, okay, after striking the reflecting surface, it will reflect back the same path. That means it will come back the same path. That means it will also pass through the center of curvature. So we can only see one line here. So this arrow shows is incident ray and this arrow shows it is the reflected ray. So the incident ray and the reflected ray lie on the same path, that is your center of curvature. This is your second rule. The third one, when a ray of light passes through the focus, it becomes parallel to the principal axis after reflection. It is just the opposite of rule 1. In rule 1, what was there? If the incident ray is parallel to the principal axis, the reflected ray will pass through the focus. Now if, in third one, if the ray is passing through the focus, then the reflected ray will be parallel to the principal axis. See, this is the third one. This is your incident ray. Okay, this is your incident ray. Now the incident ray here, incident ray is passing through the focus. What does F stands for? Focus. So it's passing through this focus, and as it moves and touches, that is strikes the reflecting surface, what will happen? The reflected ray will be parallel to the principal axis. The black line is your principal axis, so it will be parallel to the principal axis. Okay, this is your principal axis. This one is your reflected ray, and the incident ray is passing through the focus. After striking, it will be parallel to the principal axis. This is your third rule. Okay, the first and the third is just the opposite. If the incident ray is parallel to the principal axis, the reflected ray will pass through the focus. Rule 3, if the incident ray is passing through the focus, the reflected ray will be parallel to the principal axis. The last one, a ray of light which is incident at the pole is reflected back, making the same angle with the principal axis. Which means here, this is your incident ray. Now the incident ray, as it comes and it hits at the pole, okay, it strikes at the pole of a mirror. That means the center of the mirror. Pole is the center of the mirror. So the incident ray, if it strikes at the center of the mirror, the reflected ray will pass in such a way that the angle of incidence and the angle of reflection will be same. Okay, the angle of incidence, that is your I, small I, and angle of reflection, that is your R, will be equal. If I is 30, R will also be 30. If I is 50, R will also be 50. This is your fourth one. That means if the incident ray touches the pole, the reflected ray will pass in such a way that the angle of incidence and the angle of reflection will be the same. Okay, so I hope you understood the four rules. The first one, if the incident ray is parallel to the principal axis, the reflected ray will pass through the focus. Second, if the incident ray passes through the center of curvature, the reflected ray will also pass through the same path, that is center of curvature. Third, if the incident ray passes through the focus, then the reflected ray will be parallel to the principal axis. And the fourth one, if the incident ray strikes at the pole of the reflecting surface of a concave mirror, the reflected ray will make such an angle that the incident ray, angle of incidence and angle of reflection will be equal. Okay, so these are the four important ray diagrams that you need to know before we move on with the formation of images. Now, when we talk about images, you know very well what images are, isn't it? You've done this in class 7 also, and in class 8 also. You know what? You usually have the idea of an image. So when we see something, whatever gets reflected back, and whatever we see, either in front of the mirror or behind the mirror, is your image, isn't it? Not the object. The image. I'm talking about the image. Now there are two types of image which you have learned in class 7 already. So we're just revising it. The two types of images are real image and virtual image. Real image, they are formed when the reflected rays they actually meet. Okay, real images are when the reflected rays, they actually meet, and they meet at a point. Whereas virtual images are the images that are formed when the reflected rays do not meet, but meet when they are produced backwards. Okay, so remember this. In real image are formed when the reflected rays, they actually meet. Virtual images, the reflected rays do not meet, but appear to meet when they are produced backwards. Okay, the second difference is real image is always inverted. Now what do you mean by inverted? Inverted means upside down. Okay, don't mind the color, just a second. Okay, so I'm taking this to pen, though they are not identical, but still you can assume it because they are in green color. Now see here, say this is your object and this is the image. Okay, if it is a real image, if this is a real image, this will be upside down. That means, see, the head is this here, the head of the image is down. So this is your inverted. Okay, inverted means upside down. So this is your object, the image, your real image will be inverted. So upside down. Okay, upside, just the opposite, upside down. So real images are always inverted. That is, the images which you see yourself upside down, when you see any image which is upside down is your real image. Okay, and virtual images are always erect, means upright. See, the head is up, even this one the head is up. So the same way. Okay, if it's this way, the image will also be this way. That means the top and the top will be the same. Whereas for real, if this is the object, the image will be down. Okay. Third, real images can be obtained on a screen. So when you go to cinemas, the movies that you watch over there through the projector, those kind of images that you see on the screen are actually real images. Okay, whereas virtual images cannot be obtained on a screen. Real images can be obtained on a screen. Virtual images cannot be obtained on a screen. This is one of the major difference between real image and virtual image. The fourth one, real images are always formed in front of the mirror. Say this is the mirror, the real image will be formed here. Okay, somewhere here, it can be here, it can be here, it can be here, it can be here, somewhere here. But the real image is always formed in front of the mirror. Whereas virtual images are always formed behind the mirror. Okay, it's always formed behind the mirror, this way. So if image is formed here, it's your virtual image. And real image will always be formed in front of the mirror. So say this is your mirror. If the image is in front, it means it is real. If the image is formed behind, so this is your virtual. Okay. A real image we can reach to it, virtual image we cannot reach to it. Okay. So example, cinema screen. Example for virtual image on a plain mirror. When you see yourself in a plain mirror, you touch your hand with it. You won't be able to touch it. And you can touch the images on the screen. Right? Over there, the projector, you can touch those images there. You cannot touch the image that you see on yourself on the plain mirror. You touch it, the image will do the same, isn't it? So, real images can be touched, virtual images cannot be. We cannot reach to it. And example is your cinema screen, and for virtual image, the image formed on a plain mirror. Okay, next thing we'll be discussing about, we have this. Before this, we had to discuss this. Okay. So we quickly revise about difference between convex and concave mirror. A convex mirror. Okay, a convex mirror is a spherical mirror in which the reflecting surface and the center of the curvature. So concave mirror is a mirror in which the reflecting surface is inside and the silver surface is outside. Convex mirror, the reflecting surface is outside and the silver surface is inside. Okay. Second difference, concave mirror can be projected on a screen because concave mirror generally forms real images. Okay, we will be discussing that in the next class about the different types of images formed by a concave and convex. As of now, just remember, concave mirror generally, most of the time, forms real images. Okay, whereas convex mirror never forms a real image. Convex mirror only forms virtual images. That's why convex mirror cannot be projected on a screen. Whereas real images, concave mirror can be projected on a screen because they form real images. Convex mirrors are diverging mirror. Diverging mirror means the reflected rays, they diverge in all directions, they move apart. Okay. Whereas concave mirror are converging mirror because the reflected rays, they meet at one point. Convex means curved or rounded like the outside of a sphere or circle, and concave means hollowed or rounded. So the convex means curved or rounded, and concave means hollowed or rounded. So these are the differences between convex and concave mirror. In the next class, we'll discuss about the formation of images. Okay, what kind of images are formed by concave and convex mirrors. So I hope it's clear about what we learned today. Please go through your books and revise it once. And if there's any doubt, please feel free to call me. Thank you and have a good day.